Hello, my name is Brian Sullivan, and I am a student researcher at Colorado State University. Today I will be presenting our work titled An Artist's Perspectives on Natural Interactions for Virtual Reality 3D Sketching. Our team is composed of collaborators from Colorado State University, Dalhousie University, and Concordia University. Sketching is relatively new to the virtual reality environment. For our paper, we chose to work with artists to identify potential avenues to see how commercial software suits their needs, since artists are experts in the field of sketching. This is important because in the real world, artists have the option to use multiple tools and multiple interaction techniques when working. Furthermore, we wanted to see how current commercial software can help them, and if additional modifications to future sketching applications should be considered, all from the perspectives of artists. The first research question is, what tools of commercial 3D sketching systems help artists in their sketching process? For our study, we use the OpenBrush application as it is commercially available and free to download for anyone. We asked the artists how the current tools help them and if new tools would aid them in their creative process. The second research question is, what natural multimodal interactions can 3D sketching systems add to help artists in their sketching process? OpenBrush currently accepts input via the controllers, so naturally we were wondering what multimodal interactions that artists currently use would be deemed as necessary to help them in their creative process so that they could interact with the software in a more natural way. The third research question is, how do artists perceive the usability of commercial 3D sketching systems? As artists are used to working with pen and paper, or digitally through the computer via other commercial software such as Photoshop or Illustrator, we wanted to see how they would rate the current system. This was done via a system usability scale. For our study, 13 artists participated. These participants consisted of 8 females and 5 males. The sketching application we used was OpenBrush version 2.3.0, which ran on Unity 3D version 2019.4.25F1. The equipment consisted of an Alienware Aurora R14 with 32 gigabytes of system RAM and with an NVIDIA GeForce RTX 3080 with 26 gigabytes on board. The head-mounted display was an HTC Vive Pro I, and we used a GoPro Hero 7 to record the artist's interactions. For the study, every participant had to follow the steps delineated in the graphic. On arrival, each participant signed a consent form and other necessary forms for the study. Then they were asked to watch a tutorial on the basics of OpenBrush. Afterwards, they duplicated the actions they had just seen in the tutorial, but in the VR, to get accustomed to the system. Then they watched a video on multimodal interaction. The study consisted of 2 timed phases. Phase 1 consisted of the artist drawing a dog in VR, and Phase 2 consisted of adding a ground, a path, and a tree around the dog. Afterwards, the participants filled out a system usability scale. We now showed the OpenBrush tutorial. After watching this tutorial, each participant replicated the tasks in VR. These tasks consisted of switching controller handedness, selecting a brush, changing the brush size and color, drawing a cube, rotating a cube as well as enlarging and shrinking the cube, cloning the cube, undo, and deleting the cube. The second video each participant watched was the multimodal interaction video. This video showed different input modalities, such as the controller, gestures, speech, gaze, and pen. It also defined unimodal and multimodal interactions. It briefly covered the major categories in multimodal interactions. Those are synchronous versus asynchronous, symmetrical versus asymmetrical, and dependent versus independent. For the user study, we used semi-structured interviews. Semi-structured interviews are centered around a topic where the interviewer asks open-ended questions, which allows the interviewee space to express themselves freely. This allowed us to gain a better understanding of the artist that was being interviewed and allowed us to further dig deeper with follow-up questions. Thematic analysis allowed for more than one coder to analyze the data. After analyzing the separate participant data, the coders performed consensus coding to ultimately agree upon the coding and create the themes. Through the thematic analysis, we were able to find 5 main categories for unimodal interactions: creation of objects, manipulation of objects, menu actions, selection of objects, and animation. We were able to further break these down into multiple sub-interactions. Some participants did not go into details for some categories, and so those sub-interactions were grouped into undefined sub-interactions. We were able to find one main category for multimodal interactions: the creation of objects. These were further broken down into the 3 sub-interactions shown here. For the post-study interview, we conducted a system usability scale to understand the overall usefulness of the sketching application from the perspective of the artists. 6 participants rated the system with an A. 3 rated the system with a B. No participants rated the system with a C. 4 rated the system with a D, and there were no Fs. When computing the mean from those 13 scores, we got a 77.01, which translates to a B, which means that the overall perceived usefulness of the commercial sketching application was mostly accepted. Based on our findings, we were able to formulate recommendations for future sketching applications in VR. For RQ1, we recommend adding novel tools that will help in increasing the creative process of the artists. One example of such a tool is removing the menus from the viewfinder to allow the artist the whole space, which will prevent occlusion. For RQ2, we recommend adding other unimodal interactions besides the controller to allow the artist to use speech or gaze, for example, which will aid in improving some tasks. We further recommend adding multimodal interactions so the artists can mix and match interactions as they desire. For RQ3, the system usability scale gave us an overall insight into the acceptance of the sketching application. While there was major acceptance of sketching in VR, there is room for improvement, as demonstrated by the artists' comments and based on RQ1 and RQ2. We would like to thank and acknowledge the funding support from the National Science Foundation, the Defense Advanced Research Projects Agency, and the Office of Naval Research via the grants shown here. Thank you for your time and for watching this video. If you have any questions, don't hesitate to let us know. Thanks.